So in the next 40 minutes, I will be very happy to introduce to you our new addition to thermal devices family, our new device that is called TSA2 Air. This is a light, portable, air-cooled device that being air-cooled has the full capabilities to cover the full range of QST of quantitative sensory testing um, modalities. And I will be happy to review the features of this device today and then some applications afterwards. So let's start from the what this device can do and how it can be beneficial in your clinical and research work. So first of all, as I mentioned already, this device is air cooled, meaning there is no liquid running inside. Those of you who are using our previous devices, such as Pathway or TSA of previous generation, or even our newer device, TSA2, you know how to deal with liquid. You fill your device periodically, and you also know that this adds some maintenance to the picture. Of course, the cooling with liquid is the most efficient way to cool the system, and it allows to achieve wide temperature range, faster rates. But it also brings some maintenance and the need to follow up on the liquid level, to feel it from time to time. And even though we made it much more intuitive in the TSA2, the new version of the TSA, it is still requires some attention from you. Air cool system is actually a system that gives you a very low maintenance option. You don't need to keep in mind to fill the liquid before the experiment or before the day of testing, to monitor the level of the liquid and all this. And even though this is an air cooled system, we managed to achieve the full temperature range. This system can work from 0 degrees to 50 or to 53, depending on the protocol that you are following. This allows you to perform the full testing battery when you try to assess patient warm sensation, cold sensation, heat, and cold pain. Excuse me. This allows you to cover the full battery with quantitative sensory testing, and also to apply noxious heat and noxious cold stimulation. And we will discuss it in more details in next slides. Another nice capability for air cooled system is the fast rates. This system works quite fast. It works at 10 degrees per second up and up to 7 degrees per second down for cooling. um, these rates allow you to not only do the standard quantitative sensory testing at slow temperature rate, but also to do some dynamic protocols to reach your destination, reach the temperature that you want to reach fast, and shorten your experiment, lower the aggregation of pain sensation. A lot of advantages. Um, this system also has the 30 by 30 thermode, which is you can see it here in my hand, I hope. This is the thermode. This is the stimulation surface, 30 by 30 millimeters, and this is the standard surface that was very important for us to maintain. I'll tell you in a couple of seconds why. Those of you who are familiar with Medox thermodes maybe can find this thermode a little bit larger than you are used to. This because the air cool system is actually located here in the thermode. There are fans that cool the thermode down and remove the heat from the other side of the heating plate. But the good news are that even though this thermode is a little bit larger, it is significantly lighter than the thermodes of liquid cooled systems, because you don't have anything but the electrical cable here. No water tubes that make the thermode heavy, and this thermode is quite light and can be without any problems attached to any body side. You can see that also the a stimulation surface is slightly elevated above the enclosure. So this is to make sure that the only thing that touches the skin is the um, heating and cooling stimulation surface, stimulation area. It was very important for us to maintain the 30 by 30 millimeters stimulation surface of the thermode, because this is the most commonly, by far most commonly used and more widely used thermode of our medical devices. A lot of data is collected with that. A lot of research was done, and this is why it was important for us to maintain this surface. This device also has all the synchronization capabilities. It can send TTL trigger out to an external device and trigger the external device by that. It can receive a trigger from an external device, TTL in, and be triggered by that, start the stimulation, stop stimulation, start testing, etc. And this device software also has a very nice feature that is called external control, that allows an external software to some extent to control Medoc software, which controls the device. And by that, you can implement your thermal testing in a complex research protocol. You can have it combined with visual or audio stimulation. You can have it be a part of the task, that if somebody performs the task and then receive the stimulation depending on how he or she did. So really a lot of options to use this nice feature and to implement your thermal stimulation in your research experiment. If you want to hear more about this feature, if you find it relevant for your work, we have a very nice webinar on the website that you can watch and learn more about this nice feature. This device is portable. It is quite light. You can take it with one hand and take the thermode in the other hand and move around from one room to the other, from one building to the other, and use this device easily in a portable way. Of course, put it on a cart. Also very important both for clinicians and for researchers. And last but not least, all our devices, including TSA2 Air, are FDA and CE approved and also holds various types of local regulations in different countries. And this is important for two reasons. First of all, it will make it much easier for you to take your thermal device to your hospital or to your university to pass the biomedical department, the ethics committee. But second, and not less important, is that these certificates are the uh, these certificates certify our devices being safe and accurate, safe to use. We work hard to maintain this certificate. We are regularly audited by these regulatory bodies, and we need to adjust to very high standard to keep being FDA and CE approved. So this is a good thing for you to know that the device is adjusted to very high standard and is very accurate and safe. And then there are the applications. Now when then we understood what can be what this device can do, let's see what can be done with these capabilities, for what types of testing you can use it for. And these are only some examples, but I think they are quite representative. So first of all, static quantitative sensory testing, QST, a test in which you assess patient warm detection, cold detection thresholds, and heat and cold pain thresholds. You can see a very standard protocol running right now on the screen. Um, so the TSA2 Air can be used to cover the full battery of the testing, all four modalities that are part of standard protocol. Um, there is a German organization of neuropathic pain, that DFNS, that um, the protocol you see on the screen is actually the recommended by the FNS protocol, and their recommendation is to perform all four modalities, to test for cold detection and then for warm detection, then for cold pain and for heat pain thresholds. And the TSA2 Air device can do all of these modalities. Um, Due to its wide temperature range, of course, and its ability to be stable at slow rates that are required for this testing. Our software also includes all the relevant standard QST protocols. The protocol you see on the screen right now is limits protocol. In this protocol, the patient is receiving a stimulation that starts from neutral baseline of 32 degrees and goes up or down depending on the modality. And the patient needs to stop this stimulation using this response unit you can see, hopefully, in my camera, pressing any of the buttons. And by that, we find the patient thresholds. Uh, so this protocol, of course, is the one that DFNS recommends and most widely and commonly used. A lot of data collected with that. And our software, of course, and the TSA2 Air device can, of course, perform this protocol fully. Then there is a levels protocol that is quite widely used for finding cold and warm detection thresholds. This protocol fits patients who can find it hard to press the button, find it hard to understand the instructions. And in this protocol, the patient receives the stimulation, and only then he or she says if the stimulation was felt or not. And this is also possible to use this protocol with TSA2 Air. And another QST protocol is TSL, the protocol that allows to assess paradoxical heat sensation. And this is also a part of DFNS battery, so it was important for us to have it in the software. For those of you who maybe are less familiar with these protocols, you can go to our website and watch a very nice webinar on static and dynamic QST to learn more about these terms and protocols. And of course, for all this, we also need the 30 by 30 thermode, which I already mentioned. All the DFNS data that is using medical devices was collected with the 30 by 30 thermode. The normative data that is implemented in our software also and also the published normative data are based on this thermode size. So this was important for us to maintain it, and this allows us to use the existing data. When you are done with your QST testing, you can save the results, of course, and you can then export them to a very nice report that can be added to your patient file or to your research papers. And here you can see all the results very nicely presented. You have the patient data and the body side data and all the results of all the modalities that you performed. Not necessarily you would like to perform the full battery. You would like to perform only the warm detection, cold detection. You will see here the results of what you actually did. And you can see here the comparison to normative data of the suitable age and gender group. Um, and also nice graph. You can add your comments here. You can compare your today's results to the results half a year later after some treatment. So and also export it to report. Nice options. Uh, and then in addition to just assessing the static thresholds of for warm and cold sensation and for heat and cold pain, you can also do some dynamic protocols that allow you to assess the change in pain perception over time depending on the protocol. And today we will cover a couple of examples, some examples of the analgesia, which I will explain later, temporal summation of different types, and also how TSA2 Air can be implemented as a test stimulus in conditioned pain modulation. So first of all, let's start to talk about temporal summation. Temporal summation is a protocol that allows you to assess the facilitation mechanisms of the patient, how the pain is facilitated, and the main principle is to give the same stimulation and to see some increase in pain rating over time, even though the stimulation intensity does not change. And there are two ways to perform temporal summation test. One of it is phasic, meaning you have a repetitive stimulation of the same intensity, and another one is tonic, in which you just apply a long painful stimulation and ask the patient to rate the pain over time. So let's start from phasic temporal summation. So one important rule about phasic temporal summation is to maintain a quite high frequency of zero point 0.3 hertz frequency of the stimulation. So you can see that with TSA2 Air, this is achievable. You need to start from a bit higher baseline, from 37 in this case, because we wanted to reach 48. And then we work with maximum possible rates, of 10 degrees up and 7 degrees down. And we repeat it here 10 times, but this is of course adjustable. You can repeat it 15, 20 times, no problem with that. And you can see that we quite nicely fit this 10 stimuli in 30 seconds, meaning that um, we maintain the frequency of zero point 0.3 hertz. And you can ask your patient to rate first and then fifth and then the 10th stimulus and see if there is some increase in pain sensation over time in this phasic temporal summation protocol. Um, we started from a bit from a bit higher baseline, but this is really not an issue because 37 is usually not a painful temperature. And to maintain the high frequency with a rate of 10 up and 7 down, 7 degrees per second down, we started from this a bit higher baseline. So this is the phasic temporal summation. And now if we talk about tonic temporal summation, as I said, we need to give some painful stimulation over time for quite a long time and ask the patient to rate the pain during this stimulation. In this nice paper by Erika Suzanne and colleagues actually here in Israel, they assessed the temporal summation of their subjects with a long 2 minutes of painful stimulation at the intensity of 46.5, and we repeated it exactly here in the was the movie you can see on the screen. And in this case, we rate the pain with what is called COVAS, conditioned. It is not conditioned, continuous. Excuse me, pain rating device that allows you to rate the pain through all the stimulation from 0 to 100. Uh, and in this way, you can see really how your patient felt during the stimulation, and this accessory can be easily combined with TSA2 Air. Previous example was quite simple. We just went to some painful temperature and stayed there for 2 minutes. But you can also play with it and build a bit more complex protocols, let's call it. And this is a very nice paper by Stout and colleagues, published in 2020. They used a ramp and hold procedure to see if they can assess with this procedure the central sensitization and the pain facilitation in the human, and they compare it to some phasic protocol that they are usually using. So what they did, they started from 35 degrees, stayed there for a while, and then went to 49 degrees stayed there for 6 seconds, and then they went back to 35 degrees and maintained this temperature for some time because they wanted to rate the after sensation of pain, the pain that came after the main stimulation to 49 degrees in this case. So that's what they did, and you can see here the stimulation. So we start from 35, then the temperature raises to 49 degrees. Their request was to have a ramp up time of 9 seconds, so that's how they program it. You can see that in this case the participant rated the pain quite high. And the pain rating used in this case is not the continuous pain rating we saw in previous slide with COVAS, but pain rating that is recorded by the software. In this case, every 10 seconds, or maybe every 5 seconds, excuse me. And this is something that can be easily configurable. If you want your pain rating to come every 10, every 5, every 20 seconds, you can easily do that. And then this pain rating will be saved and exported with the results and can be compared with the next testing, maybe after treatment, etc. So this just showed you a couple of examples that can be performed with TSA2 Air. Another example of dynamic QST tests is what is called offset analgesia. In this paper, Marie Canisters and colleagues used it for testing pain inhibition in chronic pain patients with diabetic polyneuropathy. In case of offset analgesia, you go to some painful temperature, you stay there for a short time and ask your patient to rate the pain. Then you go just a little bit higher, only 1 degrees. And then when you come back to the previous painful temperature, you really see a very nice drop of pain sensation, even though the temperature didn't actually change. So for this, we use the following parameters, and this is again a replication of the protocol demonstrated in the paper. So we start from 47 degrees, we stay there for 5 seconds, then we go, instead of going back to the baseline and going up to 48, we go directly to next destination. This is an option that can be done with the software. We go directly to next destination of 48 degrees, stay there for 5 seconds, and then we go to 47 degrees again and stay there for 20 seconds. And we will see now how the protocol looks like on the screen. By the way, all the protocols that you see here were recorded when the device was on and the thermal was on the skin. So this is actually exactly what you will see when you will be working with the TSA2 Air device. So you can see here the increase of the temperature of the pain rating during the 47 degree stimulation, then a little bit more increase during 48. And then when we go back to 47, this is the drop I was showing to you and I was talking about. And this again is rated by Kova's device throughout all the stimulation. Um, this is an example of offset analgesia, also can be easily done with TSA2 Air. Now let's talk about CPM. Let's talk about conditioned pain modulation. So conditioned pain modulation is a test to assess patient inhibitory mechanisms. It's called pain inhibits pain. In this test, we give some painful stimulation. We ask the patient to rate it. And then we apply the same painful stimulation, but in combination or right after um, conditioning stimulus, which is another painful stimulation, and we see how one pain inhibits the other. And there are various types of, first of all, the use of thermal stimulation with medical devices is very common for test stimulus for CPM. And there are various of types of testing stimulation depending which protocol you would like to follow. You can do pain threshold using limits method before and after or during conditioning stimulus and see how pain threshold rises when you apply conditioning stimulus uh, at the same time. You can do tonic stimulation and ask the patient to rate the pain. It can be short stimulation for 5 seconds, for example, and it can be longer stimulation for 30 seconds. And then you ask to rate the pain a couple of times during the stimulation. It can be single stimulation and it can be repetitive stimulation. You can ask the patient to rate one long tonic stimulation every 10 seconds. And you can ask the patient to rate 3 stimulations for 5 seconds. It can be noxious heat or noxious cold and really anything in between. And everything can be done with the TSA2 Air device. This is just one simple example of test stimulus in CPM. So in this case, the temperature starts from the baseline of 32 degrees, goes to 45 degrees, stays there for 20 seconds, and then we ask for pain rating for ask the patient to rate the pain. Um, and then we repeat the exact stimulus, but not alone, but combined with any type of pain stimulus, of conditioning stimulus, excuse me. It can be, for example, cold water bath, or it can be another thermal, it can be pressure cuff. So you repeat the exact same stimulation, but in combination with another painful stimulation, in combination with conditioning stimulus. And then you ask the patient to rate the pain again, and the delta you receive, for example, in this case, from 6 to 2. This is the delta. This is, let's imagine that the patient, here the test stimulus was applied alone, and somewhere here the patient put his or her hand inside a cold water bath, and then received the test stimulus again. You can see exact same test stimulus and rated it much less. So this delta actually is the patient CPM effect. And this is how it can be calculated. And these were only some examples. Any noxious or non-noxious heat or cold stimulation can be applied with the TSA2 Air and can help you to build the protocol that you would like to follow. Um, so now when we discussed some applications of the TSA2 Air, let's spend the last 5 minutes of my presentation to place the TSA2 Air in the matrix of thermal devices, see where it is located related to the to another thermal devices that we sell, and maybe give you some tips on how you make a decision when you think about which thermal device will be the best fit for your clinical or research work. So first of all, right now, Medoc sells these three nice and white devices. Some of you maybe use our previous generations of thermal devices and do not recognize your pathway or your previous version of TSA here. We of course have a lot of users that still, a lot of customers that are still using previous versions of the device, but these are the three devices that we sell and offer our customers right now. So there is the TSA2 device. This is our have it all device, a device that can do really any type of thermal stimulation you can think about. It can work with standard 30 by 30 thermon or with another shapes and sizes of thermons. You can take this device with appropriate accessory to the scanner and do the thermal stimulation while doing fMRI. You can work with thermal that is called CHEPS for fast stimulation, for rapid stimulation. Really a lot of options that this device bring with it. This is a liquid cooled device. And due to very efficient water cooling, it can do all these types of stimulation. On the other edge of the scale is the QSense device. This device is a very small, nice, portative QST device. It has some limitations of a smaller range of the temperature, not allowing to perform cold pain, a little slower rates. And we will see all the parameters right now in the next slide. But it is a nice, small, portable, zero maintenance air-cooled device. And again, it all depends on what you need and which goal you would like to achieve with your thermal device. And then the TSA2 Air actually comes in between these two devices. On one hand, it is a air-cooled system, small and portable, but on the other hand, due to extended cooling capabilities, it can work in wider temperature range and in a faster rate than QSense. And just a briefly overview to different parameters that are relevant for the comparison. So the TSA2, as I mentioned, works in full temperature range from 0 to 53 at quite fast rates of 13 degrees for regular, let's call it thermals, and 70 degrees up and 40 degrees per second down for CHEPS thermals, so quite rapid. Uh, it is cooled by liquid. It has fMRI compatible accessories, and it has lots of different thermal sizes. You can use the 30 by 30, of course, but then there is a smaller. There are smaller thermals like 16 by 16 for maybe testing on the face, testing smaller body parts. Intraoral thermal that is a really small one that can be used intraorally or on another small body areas, and of course CHEPs, and there are fMRI compatible thermodes, 30 by 30, 16 by 16, and CHEPs. And the TSA2 has all the synchronization capabilities and can do all the thermal modalities from cold to heat. All types of thermal stimulations can be performed, and you can even work with two thermals at the same time. If you want, for example, to perform dual thermal CPM, use thermal for test and for conditioning, you can do this with the TSA2 device. Uh, QSense, on the other hand, has more limited capabilities, more limited temperature range, works only from 16 to 50, and at much slower rates of up to 2 degrees and even 1 degree per second for cooling. It has only the 30 by 30 thermode, and this is really a QST device. If you only want to do warm detection threshold and cold detection thresholds and maybe some heat pain, that's it. QSense is a very nice device that will suit your needs. But if you need extended capabilities like MRI, CHEPs, uh, assessing cold pain, then QSense, of course, will not do. And the TSA2 Air really, as I said, somewhere in between. It has the wide range of TSA2, the wide temperature range of TSA2, almost as fast as it, but still a bit slower, 10 degrees per second up, 7 degrees per second down. It has the synchronization capabilities that TSA2 have, and it is air cooled just like QSense with the low maintenance that it brings. Uh, and but not like the QSense, it can cover all the thermal stimulation modalities: cold sensation, warm sensation, cold pain, heat pain, tonic heat and cold, um, with its 30 by 30 thermal. Another small comparison that I would like to show is for those of you who have in your office or in your clinic this device still working, the previous version of the TSA II, TSA2, but of the previous generation. Because as we see it, the TSA2 Air is a very nice replacement for the TSA II of the previous version TSA. And for those of you who are considering now, to move to next generation and to renew your thermal stimulation equipment, I think this comparison can make a lot of sense. So you can see that the system dimension are pretty much the same. The TSA2 Air is a little bit smaller, more compact, much lighter. Uh, because it is air cooled, the temperature range is the same, and the temperature rates are pretty much the same. The TSA2 Air is even faster at heating and a little bit slower in cooling. Um, Something to mention about the TSA2 Air is that the lower you go, the slower will be the rates. So if when you approach some extreme cold temperatures, the rate will not be 7 degrees per second. But what is important to mention is that the rates of the TSA2 Air were measured when the thermode was attached to the skin with the thermal load of the skin, and this is actually what you will actually get when you perform thermal stimulation on the skin. They both have the 30 by 30 thermode, and the synchronization capabilities of TSA2 Air are more wide than the TSAI. Both can be used with the COVAS that I already mentioned, and there's the calibration of TSA2 Air, which is more wide and accurate, and can be performed automatically in automatic procedure, without the user needed to be near the device for the whole calibration procedure. And now when we excuse me, when we saw all the parameters of all the devices, I would like to present to you some decision support tool for those of you who are considering now which thermal device to go for. There are some questions that we think that are relevant to be asked. First question is, will you need these extended capabilities that we discussed? Will you need to work with your device in the scanner? Will you need to work at higher speed at 70 degrees per second, like in CHEP thermal, maybe to record evoked potentials? Will you need to use this device with two thermals at the same time for simultaneous stimulation, for sequential stimulation, one thermal on one hand, another on the other, for CPM maybe? If the answer is yes, I need it now, or yes, I might need it in the future, then you should consider the TSA2. That is the premium device that have all the capabilities inside. Then, if the answer is no, I don't really see myself do anything like that. Then the next question is, do I only need the 30 by 30 thermal? Will I only and many of you will the for many of you the answer will be yes, I need only the 30 by 30 thermal. I'm about to stimulate the hand or the leg. I'm about to do standard protocols. I want to rely on normative data maybe. I need only the 30 by 30 thermal. But if the answer is no, I might need the 16 by 16 smaller thermal. I might need the intraoral thermal. Then again, you should consider the TSA2. But if the answer is yes, I only need the 30 by 30 thermal, then let's ask ourselves if the cold pane is important. Um, will I use the cold pane, or will I only do the tonic noxious heat stimulation and that's it? So if the cold pane is important, then TSA2 Air can do just nice, given the fact that you don't need the extended capabilities and additional thermal sizes. And of course, TSA2 is always an option. It does the cold pane exactly like the TSA2 Air does, and has another possible upgrades to that. If the cold pane is not important for you, then let's see if the speed is important. Do you need the thermal to be faster than 2 degrees per second? If you just need some painful stimulation and the rate is not important, or if you just want to do standard QST, which works at 1 degree per second standard rate, then in this case, QSense will be just nice choice for you because you only need 30 by 30. You only need slow rates. You don't need the cold pane. Then you should go for QSense. But if you do need your thermal to be faster than 2 degrees per second, then you should consider the TSA2 Air. And again, the TSA2 is always an option because everything the TSA2 Air can do, TSA2 can do, and more. So I hope this will help you to to think about your next thermal stimulation device when you approach your decision point. So to recap, we just reviewed today our new TSA2 Air device, air-cooled, light, portable, the device that does the full range of QST testing and can be used for various modalities of static and dynamic QST, can perform a lot of standard protocols, and can be very nicely used in your clinical and research work. Thank you very much for listening. And now this is a time for questions. I will stop sharing my screen and then I will look at your questions. I can see some questions already inside our Q&A section. So, uh, will I be able to do thresholds at slower rates, for example, 0.5 degrees per second? Of course, if you decide not to follow the standard DFNS protocol with 1 degree per second rate and you want to use slower rates, the device will be just as stable and as accurate at slower rate. You can use even rates slower than zero point 0.5 are possible. Uh, can I attach the air-cooled Qsent thermal to the TSA2 Air? Okay, tricky question. Both systems are air-cooled, but each thermal fits its own system. The connectors are different, the wires inside are different. The thermal itself, you can see that, those of you who are familiar with QSense know that this thermal has only one fan, and therefore it is smaller, and can do less than the TSA2 Air can. So that's why you cannot switch thermals between systems. Uh, will there be a trade-in program for TSA device to TSA2 Air? Well, I will connect the person that asked that with the local distributor, and this is definitely something that you can discuss with your local distributor. Um, there's a question which is, excuse me, slightly off the topic. Is COVAS validated for pain assessment? It is. It was used in a lot of papers. Also, it's just regular VAS, and the regular VAS is validated for years, and we just offer a computerized way to do that instead of telling your VAS score or moving a slider on plastic VAS score. You can use the COVAS and to record your VAS continuous rating in the software. So yes, and there are a lot of people that are using the COVAS for years and publish paper with that. So we'll be happy to supply some if you'd like. Hey guys, I don't see any additional questions. Um, Thank you all very much for joining. And I hope it was informative for all of you. And will give you some food for thoughts. We will be very much appreciative to receive your feedback. If you have minutes, please, you will be redirected automatically to the feedback page. Please leave your feedback. Let us know how we can do better for next webinar, which topic are of interest for you, and we will appreciate it very much. Thank you all for coming. Thank you all for listening. Have a nice rest of your day.